Hello, guys.
Good morning. I'm waiting to see if Sage can make it. It'd be interesting if you could talk a little bit about the PG autoscaler. But if not, we can just proceed. Right. Maybe in the meantime, we can start on these pull requests. All right. Radic. I'm going to pick on you here because yours is the first in the list, and I know that you've got a couple others that are in the works regarding bufferless, and your hypercombined one just merged. So, want to talk at all about those?
Sure. Can you please provide link to the PR or sorry, Etherpad? Or okay, got it. It's here. Sorry,
Oh, no
just
worries.
opening
Here's.
it.
Oh, oops, that's not what I wanted. Oh well.
Uh,
Sorry.
okay. About tracking infrastructure in buffer list. Well, it seems we have the, some infrastructure related solely to debugging, tracking, to debugging in buffer list, to tracking CSTRs, to tracking allocations, deallocations, and unfortunately, it isn't cost free. It appears we are spending well. Just take a look on the output from Profiler. It's solely about CSTR on buffer pointer. It's just example of one thing.
Can we kill it?
I hope so.
I couldn't find anything that was actually using that, so it's something that we're paying for without getting any benefit from.
I have the same opinion. I'm going to deprecate all dependent methods and ask GCC to find any occurrences, any usage of the stuff. Hopefully, it will be known. So we will be able to kill it, but the buffer track CRCR is only part of the wall infrastructure. There is more, at least three things in general for tracking CSTRs, for tracking allocations, deallocations, and for tracking CRC related stuff. All that things use atomical counting. And of course, they are protected with some jump. But it seems that we have, first of all, we have some mispredictions, and maybe CPU is trying to speculatively execute those atomical instructions. Of course, they cannot retire, but I'm curious about the microarchitectural details. Might be that we have ping pong, cache ping pong on speculative, while CPU is speculating. Anyway, I'm guys, what do you think about just dropping everything related to the Ceph buffer track environment variable? Is anybody using it? Is it important?
Let me look at what it is. I'm guessing not, but I want to see. XCRC. Who added it?
I was looking through the history and I saw that Josh Durgan added at least the C-star accesses one. Was a long, long time ago.
Let's ping him to double check, but I imagine we should just kill it. I bet he added it when we were looking at doing the like kernel splice stuff to do zero copy.
Zero copy. I see.
Yeah. That's when he did it. I would just kill it.
It will be really good. The alternative is just to disable in production build using ndebug or something like that.
It's probably easier to kill it because I don't think that anybody's
Definitely. I was just speculating about plan B.
Yeah. Yeah, and in that vein, oh, you know what? There is in the unit test there's something that sets it. Oh, it just runs the unit test with it on. So whatever. Yeah. Anyway, yeah, I would kill it. And then tag Durgan on the pull request, and he can take a look. It reminds me that I think we should consider killing the CRC caching too. I'd be curious.
Or maybe dissect it to some kind of buffer list derived class. I mean, something like buffer list, but plus functionality for caching.
Yeah, maybe. I don't know if it would be usable. The intention is that we would avoid a double CRC when we CRC things coming up the wire, and then we do a CRC check again on the data when we're journaling it in file store. That's the only time when we're like CRCing the same buffer twice with the same seed. And I think we care increasingly less about that file store case. And it's just like a bunch of crap in the code.
What about check summary in Bluester? Is it being used there? Or?
Yes, but it's done on like per blob basis. So it's slices of the overall data, and it's so the granularity is usually 4K chunks, or in RGW cases, bigger chunks. So it doesn't. I don't think it's actually hitting the cache in most cases. The only exception would be in a very small rate, if it's less than whatever the blob size, which is like 512K or something. So if you put a small object, then it might hit the cache and get the same CRC. But that's a pretty narrow case, and I think it's also a small buffer to CRC in that case, so the impact is probably lower.
Okay, so it seems that caching, the CRC caching is there, but the benefit coming from it is marginal.
Very small. So yes.
Exactly. Okay, so we can just try from disabling and making some profiling to verify.
Yeah.
Cool.
Exactly. Yep. Yeah, and that's like a ton of atomics, right? And it's even got a mute fix or something. I can't remember. It's super annoying, gross code.
If I recall, we have, if I recall correctly, we have even a spin lock only to protect CRCs.
Good.
All right. So for let's move on then. For 25.421, there's a proposal to add a hard cap minimal OSD memory target, and then also manipulate the cache max and the the target value based on the kind of the base memory and fragmentation. I don't think we should actually do either of those, Sage.
Even the adjustment
Nope.
thing makes sense either.
I don't think so. What that does is basically increases the target based on the memory base, but the whole idea behind those two things, the fragmentation and the base, was to reduce things when you're near the upper boundary. You want to keep the memory kind of below the target at all times, if possible, rather than letting it kind of shoot over. So that's kind of how that works. What his PR does, from what just my quick look at it, it makes it look like what we're doing is saying, well, if the target's too low, let's increase the target so that it's kind of up around where the minimum is based on the base value and the fragmentation. We don't want that. If the user sets the target low, we want it aggressively trying to keep the cache low rather than
Notching them up.
Pushing it up.
Okay.
So that's
right.
my take on it anyway.
Yeah, go ahead and follow up on that PR, I guess. Let him know. I'll see if he has some. But I'm curious why he was submitting that.
Yeah, the basis
Supporting user
for
or something.
Yeah, I'd like to know too. I mean, the kind of the one exception for it is setting the OSD memory cache min, right? You say, okay, we don't want the caches aggregately to shrink below this value because it's just it'll break things if it does, right? That's the exception that we make. I don't think we want to muck around with the target because that's kind of what the user tells us they want. We can maybe tweak things internally, but the goal would be to keep it below that target. So everything we do should be geared toward that aim rather than potentially, increasing it to kind of not do what they say.
That sounds good.
All right. Okay, is Adam here? Not the right Adam.
No, he's waiting.
Okay. Not to say you're not the right Adam, but in this particular case, we are looking for the other Adam. So there's some stuff here for working towards sharding over column families, a lot of iterator work in the key value database. There's multiple PRs here for this. But I think the kind of the goal here is to try to start playing around with that. I still wonder if we should also be looking carefully at the difference between sharding over column families versus sharding over databases, just based on other people that have done this kind of thing and have said that, at least on NVMe, sharding over databases is the way to go, but I will defer to the people that are working on it. So that's going on. Sage, why don't you talk about your autoscaler stuff? That sounds really interesting.
Sure. This is a turned into basically a rewrite of the original module that John wrote. But it basically adds a couple new pool properties. There's a pgnum min that's optional. There's target size bytes and target size ratio that are also optional that let the user basically tell the cluster how big it thinks that the pool is going to get. So that even though the pool is empty, we can scale PGs based on what the eventual size is going to be instead of sort of ramping up PGs as we go. But in the absence of that, or incorporating that information, basically the system will look at each sort of hierarchy of the crush that we're distributing data over and add up all the OSDs and look at the target number of PGs per OSD, figure out how many PGs should be on those OSDs. And then it'll look at all the pools that are consuming those OSDs. And it will look at how much space those pools are consuming. And then proportionally divvy up the PGs, basically. And that gives it how many PGs it thinks the pool should have. And then if what it should have is off from what the current pgnum is by more than like a factor of 3, then it'll bump it up or down, and it'll always choose a power of 2 basically for that. And then you can set a mode on every pool that's either off, which means it doesn't do any of that, or on, which means it'll automatically adjust pgnum, or you can set it to warn, and it will raise a health warning if it's off if it wants to do something, but it doesn't. And then there's a new command that you run that basically does a little chart that shows all that information: the size, the target size if it's set, the ratio, the total capacity, the target ratio, the current PGNum, the target PGNum if it wants to change it, and the mode. So you can just dump one thing and you can see sort of what the cluster thinks you should do. You can either do it or not do it. You can change the mode. That's it. So the interesting thing, I think from this perspective, is if I did a little bit of like envelope math, and it's basically if you create a pool with like 1 PG or whatever, you don't give it any information, and then you fill it up. Say you were to write, a petabyte. And the question I wanted to answer was how much data, how many times is it going to split, basically, and how much data is it going to move when it splits? Does that? How many? So what's the overhead of like not tuning everything versus like telling it exactly how big it's going to get so it doesn't have to do any splitting or merging? And it turns out it doesn't actually really matter how many times it splits or makes adjustments. That's sort of at the margin, because what's actually happening is the amount of data movement is like it's a series of a half plus a quarter plus an eighth plus a 16th plus a whatever, depending on how many times out. So it's in the limited approach is 1. Basically, all data will move exactly once, which means that if you were to write a petabyte, then the data will basically write. Well, it's going to write 3 petabytes because it's triple replicated, and then it's going to also move 3 petabytes because every object is going to move approximately once if it's automatically managing everything. So I guess the nice result is that it's bounded. And if you want to do better than that, then you can tell the system ahead of time how big the pool is going to be, and then we can avoid doing those adjustments. Yep, that's it. I think the only thing to point out is also that when this makes adjustments, it just sets it to what the PGNum should be, and there's already a piece of code in the manager that will basically make small adjustments to the PGNum, and it throttles that based on the percentage of degraded objects. They set a global threshold that you want no more than 5% of your cluster to be not degraded but misplaced. Sorry. A max displaced, basically. That's a global setting. And it affects what the balancer is doing, and also affects how quickly the PGNum is adjusted. And so it'll always sort of keep you under or around that band when it's making PG increases or decreases. I think it defaults to 5%. That's it. I think it's basically ready to go. There's some manager interface refactoring stuff. I want to merge that first and then merge this after. I think. Then I'm fixing the tests.
Cool. Let's see. So what else?
The hypercombine bufferless merged.
Yep.
Woohoo. That's good. That's exciting. Radek, I'm wondering if there were some like high level, what that high level net takeaway was in the test that you were running. Like how much of an impact did that make in your
around? Well, I was testing the whole branch all together with hypercombining, with killing append buffer, etc., etc. It was in general it was around 5%.
Cool. Okay.
4.5 up around 4.5.
What kind of test was that, Radek?
4K random reads over on Inserta. Still I made it quite long time ago. It was only one node. So a lot of contention there. Both clients and OSDs the same node.
Okay. And most of those other pieces are in, right? The append buffer. No, the append 0. That's something you're still working on.
Yes, I have
getting
a
this on the
big
side.
branch with this stuff. Let me provide the link. Basically, I have the switch already made. I'm refining this stuff, and I hope we'll be able to send it soon. Okay, got it. Here it is. It's not rebased on top of the newest things, newest incarnations of hypercombined of append buffer. It's a continuation of the initial branch.
Okay. Cool. Okay. Great. Anything else that we should talk about? Is there an update on the VLA branch?
Yes, I responded to some feedback, and thanks for Casey for pointing out that libfmt is already available. So we've got that available now in RGW, and basically all the kind of gnarly append calls that I wasn't very happy about are now lib format, or rather libfmt. So it's ready for another look if anyone has free time and wants to have some fun. That's all.
Cool. Looks like this is all in RGW. Is that just because that's where all the VLAs are, or is it?
That's where most of them were, and basically, tracking them all down is just a bigger project, and I kind of picked this one partly because I had the blessing to do it, and partly because I thought it would be a fair case study of what the typical usages in Ceph look like. And sure enough, most of them are things we can probably replace with stud string, and for the most part, the rest of them can be replaced with vector. There was, I think one case I ran into where I did, and Joao pointed it out. I replaced a non-VLA with a vector call, and I think the reason for that, as I recall, was that I had just written some string transform function in a way that wouldn't take that array. I can revisit that or leave it as is. It's a 16-byte buffer in this case, so I don't think it'll matter.
Ready for test and review?
Yeah, it's passing whatever unit tests we have. It's certainly ready for review. The kind of error that I would be suspicious of is it's possible I've introduced some off by ones or something like that, just because juggling null handling, especially when you're converting the string, is a little tricky. But I think I got it. But that would be, please keep an eye open for that.
Cool. Okay.
Thanks. I'll give it a more detailed review.
Great. Thank you very much.
Cool. Okay. Anything else we should look at here?
I was going to just mention, Sage, that on the librd shared persistent read-only RBD cache, we got new benchmarks where they did test in cases where they didn't have as much cache as they had size of, aggregate volume size. Mm-hmm. And it was consistently better. Sometimes not nearly, to the extent that the other tests showed, right? Where it was just slightly better. But it doesn't look like in any of the tests that they did there, it was ever slower, which is nice to see.
Awesome. That's what we want to see. Yeah. Cool.
Yep.
Okay. Should make sure that Jason knows that I think that's the one that's in a state or close to a state that I can actually get merged. The right back one is, I think, a bigger project, but I think that one's more closer to ready. Cool. All right. Excellent. Anything else? Anything else we should talk about?
Um,
I would love to. I would like to ask for reviewing the branch with that kills append buffer. Basically, it plays very. I hope it will plays very nice with hyper combined buffer list because killing append buffer would mean that I would expect that the average value of the nref counter across across buffer rows will drop dramatically. And it's quite important because in hyper combined buffers have only one slot for buffer pointer.
So basically, it's saying if we append something that's short, then we copy it in, or is it what exactly is the change here?
It switches.
Oh, append buffer, the internal buffer. Got it. I understand. Yes.
Yes, exactly.
I see. I was changing the interface.
It uses alt playing C pointer instead of buffer pointer, which means there are less atomical operations, less references to particular buffer row.
Okay. And so when you create a buffer list, it's empty, and when you append like a short C string or something to it, it will allocate a buffer that's 4K, just like append buffer was, but it'll be the buffer point.
The same behavior preserved.
Basically. Okay. Awesome. Yeah, that sounds great. And it looks like the micro benchmark looks good too. Like 50%. No, 30%. No, micro. Well, less than that. But it helps. Yep.
Also, there is another branch. I just killed the work in progress prefix and put performance label. It's about optimizing. Atomical operations for buffer rows. Can be useful for the case where buffer list isn't shared. I mean, something like using buffer list instance just to encode or something like that.
Do we use clone anywhere right now?
We do. It was in copy constructor to take care of those buffers that aren't shareable, that can't be shared.
When does that happen? When our buffer is not shareable?
I saw some implementations of row that uses that thing. It was maybe about RDMA or something like that.
Yeah, I think we added this for the XIO messenger, but I don't think it's actually used anywhere right now. Yeah. I'm just wondering if we still need this.
Yeah, I tried to kill. I tried to kill that and found some occurrences, unfortunately.
Casey, do you have any thoughts on this?
So, I mean, if it's only XIO Messenger and XIO Messenger isn't interesting, then I think we should remove it.
I guess. Yeah, I mean, yeah, that seems like that's the default path. We'd probably just remove XIO Messenger itself from the tree at the same time. But I guess the question is this concept going to be useful elsewhere? I don't know if the current RDMA stack for async messenger uses it or not. But shareable.
Yeah, I think it's an interesting concept to have something that won't be shared and copied instead, but I don't know if that's the best way to do it.
I actually don't even see the users in make shareable. I think make shareable, but I don't actually see any callers anywhere, even in the biocode.
Make shareable, I mean buffer list make shareable it was used only internally, if I recall correctly, in constructors buffer list and in claim append. But I stripped the method from the interface and well, used something different for those two use cases. Anyway, the PR is more about initial ref counting and decrementing the counter where you are sole user instead of just cloning.
Like it's applied to all data payloads, actually, on messages. Cool. I just worry this is adding complexity that we're not using. And if the direction is to try to simplify the buffering model for the C-star messenger, then not sure how helpful this is going to be.
Well, the intention is to help. The intention is to help is to help those use patterns, those use cases that doesn't require extensive sharing. I mean, I'm trying to minimize the cost of sharing behavior of shallow copy of buffer list to such extent. Let me rephrase.
Yeah.
I would love to have a buffer list implementation that doesn't impose costs on features that are not being used by in particular scenario. Sharing in is one of those cases.
Right. Okay.
I'm perceiving buffer list as some kind of scatter-gutter list implementation with shallow copy. And everything's fine, but at the moment we are we are doing a lot of atomical operations, even where there is no possibility of sharing. If somebody creates a buffer list, calls append on it, he needs to create a new buffer row, the initial buffer pointer owning that row, etc., etc. Unfortunately, even when the freshly fabricated buffer row is obtained by the by the owning PTR, well, the bumping up the NRF counter is made atomically, completely unnecessarily. That's the reason for introducing the reason for conveying, for adding some information to buffer to type system, meaning that a bit of information about ownership, something like a unique pointer, but without its managing behavior.
Right.
The same, analogical thing during destruction of buffer pointer. It tries to destruct the instance, keeping counter intact. I mean, if the NRF counter is equal to 1, this means we are owner. and we don't
Yeah,
need
we don't
to
need to
bump down it atomically.
Right. So I guess my question is the shareable sort of tracking or whatever in here, is that helping, or is it just something else to deal with for this
Sorry,
effort?
do you mean is shareable?
Yeah, right.
Well,
So
it
in your
was
effort to
the
avoid
first
these
commit.
atomic operations, is it?
I guess you are talking about the first commit. It's there is an optimization for calling for ensuring that there is no buffer requiring copy on share, like we do during like we do while copy constructing a new instance of buffer list. We were iterating over those all our buffer pointers to verify to verify whether the cloning is necessary or not. It was made with make shareable. I moved some those bits to the cloning the cloner of PTR node we got in the hypercombined thing, in the hypercombined PR. It means that also during cloning, the buffer pointer can be allocated altogether with the clone of buffer row, buffer pointer, etc.
Got it. Okay.
Basically, it extends a bit the hypercombined behavior also to clones, but I'm not sure about its real usability. Maybe cloning is quite infrequent.
Okay. Okay. Anything else? I'll go ahead and I'll review that the first one. I mean, optimizing the reference, it seems like kind of a no-brainer. My only reservation is just maintaining the hyperconverged stuff or the shareable stuff, but we don't have to drop it now. We can always come back to that later. But the other one, the longer one, the pen bench and buffer one also looks good. We'll review that one too. Anything else we should talk about?
What do you feel about introducing some kind of contiguous reserver? I mean, optimizing the old encoding infrastructure.
I'm hesitant to like keep spending too much effort optimizing all this old stuff, as it feels like that it's diminishing returns.
Well, it wasn't actually. I made that comment some time ago. The matter is mostly about the quirkiness we would add by magic. Let me point to Euler commit. Meta PR. Okay, got the commit. Here it is. made some comparison of before and after. Here is also the gist. From profiling, it seems that, well, the old infrastructure is still very popular, even more than the dank stuff. And optimizing them, well, this was the part of the dead code elimination idea. The the compiler optimization called DCE.
I'm wondering if the old code, a lot of that code is the assert calls versus, because I know that a lot of those end methods just have a bunch of asserts. I don't know if we can get some of the benefit just by figuring some of those out.
Radix assembly, that doesn't look like asserts in there really much.
No, but they.
Yeah, I guess not. They're all doing calls onto. I see, because they're not getting inline; they're doing actual calls versus the new one. It's all inlined, right?
Yes, the idea is to make the assembly of encode stuff so short that compiler wouldn't be prohibited from aggressive inlining. At the moment, that's not the case. We have a lot of calls, even to append of buffers that cannot be inlined because it's in CC. And moreover, we are spending a lot of instructions, a lot of code just on filling on the call invocation, basically, on preparing, on putting the stuff to arguments to registers, calling append, etc.
Okay.
I made.
So is it working because
Yes,
because you have a
it
series
passes.
of encode calls, each of which is like adding an 8-byte encoding like an 8-byte field, and you don't know how many of those are. How is it inlining and combining the checks that there's enough space to do a bunch of
DCE, dead code elimination. The compiler tracks it tracks the number of bytes using a chunk size known at compile time. In this particular case, it is 64 bytes. And if somebody encodes, compiler can, in some cases, it's able to know, it's able to kill the if.
all the ifs, because it knows that it can actually at compile time it can track the size of the.
Exactly.
That's pretty awesome. Okay. So this sounds good. This would actually help a lot in the MDS too, because it's also doing a lot of its CPU time is spent doing encoding the structures, and
there is also a significant cost. I mean, wideness. Just take a look on the commit. We are basically reusing the encode start macros. We are it's basically a hack, to be honest. Let me point out particular line. Code. Okay, got it. It's a bit hacky.
where it's just declaring the reserver decode. Doesn't look terribly offensive. What does the actual contiguous reserver class look like?
It's a bit similar to contiguous appender. It's defined in the buffer.h.
So it's got a reference that's going to get compiled out. It's got a 1 byte reserved counter and this reserved T. So I don't know. And these both get optimized away basically, right? So this whole structure gets optimized away.
Well, then I guess the len will resist. But still, it can be much faster comparison to what we have at the moment.
Can you rig up like a unit micro benchmark of some sort that actually tries to encode a bunch of structures?
I guess I already made it in the big branch with maybe I have results. I can recall it was maybe of course depending on the particular encode. Well, if encode mixes a lot of C string appends with buffer list appends, well, it's much worse. But if there are only C strings,
I see.
well,
Yeah.
everything's is really good.
Yeah. Okay. It sounds good to me. Might be good to get somebody else's opinion here. I don't know who else should look at this. Maybe Kifu.
Still, it's at the moment it's in the development branch. It requires, if I recall correctly, there is a dependency on killing append buffer to have this possible.
Well, let's do that first.
Yeah.
Okay.
The same with deduplication of zeros during append 0. It's implemented. It's in one. It is in the development branch, but the branch is pretty big, and I would love to avoid such.
Yeah.
I would love to not repeat the OptTracker history.
Sounds good. Okay. All right. Well, I'll start with the pen buffer and then optimize reference counts. Those are the two to look at next.
Thanks.
All right. Anything else? All right. Thanks, everyone. Have a good one.
Thank you.
Bye, folks.
See you guys.
Bye-bye.